Hello, good morning everyone. Let us start today's lecture on 3D geometry. Yesterday I explained about direction ratios, direction cosines. They are most important. Okay, so just I am going to recall them. Today's lecture is most important because we are going to learn many things in 3D. Now let's see here. Yesterday I explained about direction ratios and direction cosines. What is direction cosines? The angle made by x-axis is alpha, the angle made by y-axis is beta, the angle made by z-axis is gamma, then cos alpha, cos beta, cos gamma. The cosine angles of alpha, beta, gamma are called direction cosines. Yesterday I explained this thing very clearly. So here, if I am taking in the space x-axis, y-axis and z-axis, OP is a vector, OP is a line, OP is a vector, then this vector can be written as unit vector. If it is not unit vector, we can make it as unit vector. See here, OP is a vector that can be unit vector or non-unit vector. If unit vector, that's fine. Okay, if non-unit vector, suppose I am taking 2i plus j plus k. This is a non-unit vector I am taking. Now, how we can make this as a unit vector? We can square, we will find the distance, means we will find the square root of magnitude of this vector. Magnitude of this vector is under root of 2 square plus 1 square plus 1 square, that is root 6. The magnitude we will divide by that plus or minus, that will give you unit vector. So the unit vector which makes the angle with x-axis, y-axis, z-axis, they are called direction cosines. The unit vector which makes the angle with x-axis, y-axis, z-axis, they are called direction cosines. So the OP vector is equal to Li plus Mj plus Nk, where L, M, N are called direction cosines. Cos alpha, cos beta, cos gamma are called direction cosines. Means a line, a vector line which makes the angle with x-axis, y-axis, z-axis, they are called as direction cosines. The angle are not direction cosines. Angle they makes, but the cosine angles of that is direction cosines. Means cos alpha, cos beta, cos gamma are direction cosines. And these all we have learned yesterday. Okay, if any unit vector which makes the angle with x-axis, y-axis and z-axis, that is called direction cosines. So we can say that OP vector is equal to Li plus Mj plus Nk. Okay, and any vector which is parallel to the given line, suppose A vector is equal to A1i plus A2j plus A3k, then if this is a vector, A vector is equal to A1i plus A2j plus A3k, then the direction ratios are any vectors whose direction ratios are the components of this A1, A2, A3 are called direction ratios of this vector. Okay, A, B, C are direction ratios of a line. For a line, A1, A2, A3 are the direction ratios. They are the the A1, A2, A3 will be any vector is there which is parallel to any given line. So then A1, A2, A3 are called direction ratios. These are direction ratios. If then its direction cosines will be, yesterday I proved this one, plus or minus a upon under root of a square plus b square plus c square, plus or minus b upon under root of a square plus b square plus c square, plus or minus c upon under root of a square plus b square plus c square. These are the direction cosines of the given direction ratios. So this proof I have given yesterday. Already I have given one more proof, what L square plus m square plus n square is equal to n. That means cos square alpha plus cos square beta, means cos square alpha plus cos square beta plus cos square gamma is equal to 1 I have given yesterday in the proof. So based on this concept, let us solve some problems. You will understand more clear. Let us see this question. So find the direction cosines of the line segment joining the origin with this point. Okay, so what is the meaning of this? I just told you just in the before lecture. To make you understand, that is the reason I explain once again, because this is most important concept, and now we are dealing this. Within 10 days I'll finish this chapter. Okay, let us see, a point is there here. The point is 2 comma minus 3 comma 6 with origin here O 0 comma 0 comma 0. If I join this, that's what he's saying. Find the direction cosine of the line joining the origin with this. So he is asking, line joining with this, you have to find direction cosines. I told you this, if it is a vector, so OP is a vector, OP is a position vector. What is a position vector? OP vector will be, the position vector of OP is 2i cap minus 3j cap plus 6k cap is the position vector of this. Then the direction, if I want to find direction cosines will be, how to find direction cosines? I told you, you have to find unit vector first, unit vector of this, right? I told you unit vector of this, that will be give the answer. So OP vector is the direction cosines when happens if the magnitude is divided by that. So what is the magnitude of this? When a square root of direction cosines, if I want to find square root of this is 2 square plus minus 3 square plus 6 square. I am making this vector unit vector. So I am going to get as 2 square value 4 plus 3 square value 9 plus 6 square value is 25. Okay, so 6 square value is 36, sorry, 36. So I am going to get a square root of 49, that is equal to 7. So this OP unit vector will be what? Unit vector will be plus or minus 2i minus 3j plus 6k cap divided by 7. So what is direction cosines here? These are the direction cosines. No? What are the direction cosines here? OP vector is the direction cosines of this will be, direction cosines of this vector will be plus or minus 2 by 7, like here this is cos alpha, right? Cos alpha is equal to LMN. I told you this is what we can write, OP is equal to plus or minus 2 by 7 I cap minus 3 by 7 j cap plus 6 by 7 k cap. In the morning lecture I told you this vector can be written as Li plus Mj plus Nk vector, and these Lmn are called direction cosines. So this I explained, plus or minus 2 by 7 plus or minus 3 by 7 plus or minus 6 by 7. It means L, M, N are these. So direction cosines are plus or minus 2 by 7 plus or minus 3 by 7 plus or minus 6 by 7. These are called direction cosines. Hope you understand what I had explained you. Direction cosines you will going to get. You have to find the unit vector of this, and this is most important, you know. This is direction cosines of this. So plus or minus 2 by 7 I cap plus or minus 3 by 7 j cap plus or minus 6 by 7 k cap. I had told you that if this is expressed in Li plus Mj plus Nk form, it is a unit vector, then that is Li plus Mj plus Nk, then L, M, N are direction cosines. So the direction cosines are here plus or minus 2 by 7 plus or minus 3 by 7 plus or minus 6 by 7. Let us see next question. Now let us see the one more question here. If a straight line makes an angle 60 degrees with x-axis, 60 degrees with y-axis, find the angle it makes with z-axis. This is the question. So one thing you should know, that the angle which made by alpha, beta, gamma with coordinate axis always lies between 0 to pi. Remember this thing. The angle made by alpha, beta, gamma with the coordinate axis will be 0 to pi. That will be lies 0 to pi, not more than pi. Okay, that you have to remember, 0 to pi in between. Okay, so this will be there. So what I do here, if a straight line makes an angle 60 degrees with x-axis, this is cos alpha. So x-axis means cos alpha. Cos alpha is given 60 degrees. It makes y-axis with cos beta. Cos beta is equal to how much? 60 degrees. What is the angle makes by z-axis? That is cos gamma is asking to find. So just now I explained you cos square alpha plus cos square beta plus cos square gamma is equal to 1. This is what you have. So cos square alpha means cos 60 degrees. Cos 60 degrees value is how much? 1 by 2. So right, cos 60 degrees is 1 by 2. 1 by 2 whole square plus 1 by 2 whole square plus cos square gamma is equal to 1. 1 by 2 means 1 by 4 plus 1 by 4 plus cos square gamma is equal to 1. Okay, so what I am going to get here, 1 by 4 plus 1 by 4, that is 2 by 4, that is half, right? This will be half. So cos square gamma is equal to 1 minus half. So cos square gamma is equal to half. So you got what here? Cos square gamma is equal to half. Then cos gamma will be how much? Cos gamma is equal to plus or minus 1 by root 2. So plus or minus 1 by root 2. So cos gamma can be happen plus 1 by root 2, or cos gamma can be happen minus 1 by root 2. Cos gamma 1 by root 2, when you get cos gamma will get 1 by root 2 if it is cos is pi by 4. So gamma is equal to pi by 4, that is 45 degrees. But this cos can be in the second quadrant also. This can be in the second quadrant. Second quadrant means pi minus cos will be pi minus pi by 4. Pi minus pi by 4. That is okay. So you can get in cos pi by 4 also, no, right? Cos pi minus pi by 4 I can use here, right? So here I can use cos pi minus pi by 4. So that is, you know, 180 minus theta, cos 180 minus theta will be minus cos theta, right? Cos 180 minus theta will be minus cos theta. So here pi minus pi by 4 will be how much? 4 pi minus pi, that is 3 pi by 4. It means in this case this will be cos gamma will be equal to cos 3 pi by 4. So gamma can be pi by 4 or 3 pi by 4. This is the answer. Hope you understand. Let us go for the next question. So let us see now one more question here. Concept here, the direction line segment, direction ratios of a line segment joining the points x1 comma y1 comma z1 and x2 comma y2 comma z2 are. The direction ratio, suppose there is 2 points. One is the point is x1 comma y1 comma z1. Okay, x1 comma, you have a point x1 comma y1 comma z1, and you have another point x2 comma y2 comma z2. So then if you join these 2 points, then you get vector. That is what you get, vector. So AB vector will be what? AB vector nothing but x2 minus x1 I cap plus I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. This is the vector. So these vector components are called direction ratios. So direction ratios will be what? The direction ratios are x2 minus x1. This is one direction ratio. Direction ratios are also used like this. Okay, they will use like symbol. Okay, so direction x2 minus x1 comma y2 minus y1 comma, and then other one is I can use as z2 minus z1. So what we can say that these are the direction ratios. So x2 minus x1 comma y2 minus y1 comma z2 minus z1 are called direction ratios if you have a 2 line. Okay, then what is direction cosines for this? Direction cosines means we will divide by the magnitude of this. So let us solve a problem based on this concept. See, this is the question. Okay, this is purely important for the board level. Okay, and even you should know this concept. Okay, fine. So let us see here. This is the question you have. Find the direction ratios of the line segment joining these 2 points and find the direction cosines also. He is asking to find direction ratios and direction cosines. Okay, so there is one point is 1 comma 2 comma 3, another point is here 2 comma minus 1 comma 4. To understand, make easy, I am using this concept here, like AB is there. So AB is a vector. So direction ratios will be what? Direction ratios can be used as like this. Okay, so you can write x2 minus x1, 2 minus 1, 2 minus 1 is 1, and minus 1 minus 2, that is minus 3, 4 minus 3, that is 1. These are the direction ratios. So these are the why we call direction ratios? Simple is AB vector will be what? What is the AB vector here? 2 minus 1 I cap minus plus minus 1 minus 2 minus 1 minus 2 j cap plus 4 minus 3 k cap. Now you can get how vector will get when you subtract the, you will get the vector. So this is I am going to get I minus 3j plus k cap. So this is the vector. So components of these are the direction ratios. That's very simple. Okay, you understood now direction ratios. Now what is direction cosines here? Direction cosines are what? If you take the unit vector of this, what is the unit vector of this? Unit vector will be what? I will find the magnitude of AB. What is the magnitude of AB here? Square root of 1 square plus minus 3 square plus 1 square. This is the magnitude of this. So this value will give you how much? 1 plus 9 plus 1. That means under root of 11, right? So this AB unit vector will be how much? AB unit vector will be 1 upon root 11 I cap minus 3 upon root 11 j cap plus 1 upon root 11 k cap. These are the unit vector. So what is the components of unit vector here? Components of unit vector is what here? 1 by root 11 comma minus 3 by root 11 comma 1 by root 11. So simple. Now you understood. This is direction cosine and this is direction ratios. Direction ratios are more important, useful than direction cosines. And direction cosines looks easy. Direction ratios are looks easy. Direction cosines are little bit complicated. But this is the concept of direction ratios and direction cosines. Hope you understand very well. So let us see one more question here. See, this is most important board question. Many times asked. This is most important board question. See here, if alpha, beta, gamma are the angles made by the line with positive direction of x-axis, y-axis, z-axis, prove that sin square alpha plus sin square beta plus sin square gamma is equal to 2, cos 2 alpha cos 2 beta plus cos 2 gamma is equal to minus 1. Even these are important for JEE point of view also. But I am covering each topic with boards JEE all together. I am covering. So this is very important one. Okay. So alpha, beta, gamma are the angles made by the line positive direction. So what do you know? Alpha, beta, gamma are the lines made by positive direction of x-axis, y-axis, z-axis means they are direction cosines. So what I can write here? Cos square alpha plus cos square beta plus cos square gamma is equal to 1. This is we know already, right? What we can write here? These are direction cosines. They are made, means the meaning of that means they are nothing but we know that angle made by. We have to write like this. When you are writing in boards, you have to write this alpha. The angle made alpha angle made by positive direction of x-axis, that is equal to L is equal to cos alpha. Beta angle made by positive direction of y-axis, that is M is equal to cos beta. Gamma angle made by positive direction of z-axis, that is equal to N is equal to cos gamma. We have to write like this. Then we know that L square plus M square plus N square is equal to 1. We have to use this concept. So cos square alpha plus cos square beta plus cos square gamma is equal to 1. We are using this. So here we are used this here already. So cos square alpha can be written as what? 1 minus sin square alpha. So this is I can write as 1 minus sin square alpha plus 1 minus sin square beta plus 1 minus sin square gamma is equal to 1. So 1 plus 1 plus 1, that is 3. So I can write as, I can take as 3 minus common out, sin square alpha plus sin square beta plus sin square gamma is equal to 1. I am going to get it. So if I send 3 that side, minus of sin square alpha plus sin square beta plus sin square gamma is equal to 1 minus 3. That is minus of sin square alpha plus sin square beta plus sin square gamma is equal to minus 2. Minus minus cancels. The first one is proved. This is what we can do it. Now let us go for the second question. So second question, what is said here? It is said that, okay, it is said that cos 2 alpha plus cos 2 beta, that is equal to cos 2 beta cos 2 gamma is equal to minus 1. It's most important question, okay, 100% important question. So what I do here, we know that already the system we wrote. So what we write as cos square alpha plus cos square beta plus cos square gamma, that is equal to, you know, this is 1, right? This is already, you know, this is 1, correct? So you have here, you got, this is you proved already, right? So what you have proved here, sin square alpha plus sin square beta plus sin square gamma, that is equal to 2, you have proved here. So you have to use a logic here and a formula, that's it. So you know that 1 minus 2 I am doing. So what I am going to do, if I do subtraction of these both, I get as cos square alpha minus sin square alpha plus cos square beta minus sin square beta plus cos square gamma minus sin square gamma, that is equal to 1 minus 2 is how much? Minus 1. And this is, you know, what is this? Cos 2 alpha. This is the formula. Okay, cos 2 alpha plus cos 2 beta plus cos 2 gamma, that is equal to minus 1. We have proved these both. Okay, hope you understand. This is the beauty of mathematics.